Now we're going to do some word problems on page 14 and 15. First, I want you to look at number 2. Now, for number 2, we're going to use a table. And the question says the sum of 3 consecutive odd integers is 105. What are the 3 integers? Okay, well, I have 3 unknowns. What are my 3 unknowns? My first consecutive odd integer, my second consecutive odd integer, and my third consecutive odd integers. And they talk about the sum, so I know I'm going to have a total of all of my integers. Okay, so if my first consecutive odd integer is x, because I don't know what it is, so I'll call it x, my next consecutive odd integer would be x plus 2. Now some of you might think, why plus 2 if it's odd? Well, let's think about it. 1 is an odd integer. What's the next consecutive odd integer? It's 3. What do I have to add to 1 to get to 3? I have to add 2. The next one is 3. What do I have to add to 3 to get to 5? 2. So I'm adding 2 even though they're odd. Now, what do I have to add to the first to get to the third? Well, I'd have to add 4. Okay? So now, in terms of x, what's my total? Well, I have 1, 2, 3. It's 3x plus 6. And according to this problem, when I add my consecutive odd integers, I get 105. So this table defines our unknowns, gives me the equation, and leaves 3 blanks for me to answer. So I now know I have to answer this, this, and this. So I'm going to solve this equation. By this point, these 2-step equations are easy peasy for everybody. We get 3x equals 99, divide by 3, x equals 33. Okay, well if x is 33, 33 plus 2 is 35, 33 plus 4 is 37. And what's really nifty about this chart is now I can add 3 plus 5 is 8 plus 7 is 15, carry the 1. And look at that, I was able to check my answer that those 3 consecutive integers did indeed add up to 105. So I like these charts. Okay, now the next one we're going to do is number 4. And number 4 says 1/3 of a number. Well, I'm going to let n equal number. And 1/3 of a number would be 1/3 n plus 3 times the same number is the same as. Well, that means equals that number n plus 14. Okay? So I just actually let n equal number and I translate across. Now how are we going to solve this? Well, I notice we have a fraction, which is very annoying. So there's different ways you can approach this. I can try to combine all of my n terms first, but in general, working with fractions can be tricky. So something else I can do before I even work with the fractions is clear the equation of fractions. Okay, so I'm going to multiply both sides by 3. 3 times 1/3 is n. 3 times 3 is 9n. 3 times n is 3n. And 3 times 14 is 42. n plus 9n is 10n equals 3n plus 42. I'm going to subtract 3n from both sides, and I get 7n equals 42. Divide by 7, n equals 6. Now, that's one way to do it. That's my favorite way, and I get n equals 6. Some of you will say, I don't mind working with fractions. Okay, that's fine with me. So, 3 1/3 n equals n plus 14. I'm going to subtract 1n from both sides. I get 2 1/3 n equals 14. So 7n equals 14. Multiply this by 3, multiply this by 3. 7n equals 42. Divide by 7, divide by 7, n equals 6. That's another way to do it. Okay, now turn to page 15, and we're going to do number 10. So number 10 says, the Sun Spa charges annual dues of $125 plus $10 per hour to use the facility. So Sun Spa charge is 10 per hour plus 125. The Moon Spa charge is 7 an hour plus 230. For how many hours would the two spas charge the same? Well, when does the sun charge equal the moon charge? Well, I would let 10h plus 125 equal 7h plus 230. I'd subtract 7h from both sides. 3h plus 125 equals 230. Subtract 125 from both sides. 3h equals 105. Divide by 3, divide by 3. H equals 35. So the answer would be, after 35 hours, it would be the same charge at both.